Great. Thanks everybody for joining. This is an overflow session. Actually, we ran this session on Tuesday, and a bunch of people couldn't attend. We had hundreds of people register and sign up. We actually maxed out our webinar account, so we've upped our maximum. If you couldn't get in to the last one, I apologize. Thanks so much for joining us for the second version. This is actually part of a three-part series that we put together just based on feedback from clients and from the industry as a whole. I think the myths and hype around cloud from vendors and from rumor and tech blogs is a little bit fuzzy. And so we've taken, all those conversations that we've had with clients and with our technology partners and tried to condense it. This first part one, is an overview. So end to end of kind of modern analytics architecture, specifically on the cloud. So focused on what makes it different on the cloud than it has been for the last 10 or 15 years. Part two, which we're going to do on Tuesday, I hope you can join, is a deeper dive into the first half of the architecture. So if you think of like the integration and storage part of the pipeline, that's where we're going to focus, and I'll do that one on Tuesday. Please come for that one if you're kind of in that data engineering, data pipeline orchestration mindset or role, or you're just curious. And then part three is going to be our deeper dive on data warehousing and data science, kind of the last mile of analytics, again, specifically on the cloud. That is the following Tuesday, so the 30th, I believe. So hopefully you can all come for that. Let me just quickly introduce myself. Hopefully you guys can see this. So my name is Chris. I'm based here in Calgary, so I run nucomp's analytic business for Western Canada. nucomp's head office is in Toronto, but we're all over North America and the Caribbean, which is why it's fun to bring together, 400 or 500 different experiences across all of our clients and condense it for you. So hopefully you have less false starts and you can borrow some ideas from us. My background, is much like the story I'm going to tell today. I grew up in analytics before it was cool, and the world has changed, and I've had to adjust my knowledge and role and then raise up other consultants and technologists in this new paradigm. So I'm going to give you some of the things and tools that I use to kind of get up to speed to be able to deploy analytics today. How is today going to break down? We're going to go through the cloud specifically in terms of analytics. I don't think I need to explain the cloud to you, but I'll talk about some basics of it just so we all agree on terminology and structure, and then really take that, what is the cloud, and apply it to analytics and data architecture and modern business intelligence. And a bunch has changed. It really has. I think there's a lot of resistance to change. We're trying to take old patterns and blueprints and apply them to a cloud paradigm. Some of that works where you can just lift and shift. Some of it for sure does not. So I'm going to try and call out the biggest changes, like the gaps from the way we used to do it to the way that we do it now. Doing that takes new skills, and sometimes that's uncomfortable to talk about new skills, and that we might have to change and adapt. But I think it's an opportunity. What we are seeing is a consolidation of roles. So if you used to be an ETL developer, you are now, data engineering is this software development, BI, data warehousing, data governance kind of role. And I'm going to talk about the definition of those new roles and try and give you some pointers to get there. Then we have to migrate not just ourselves, but the actual infrastructure, right? So databases and assets and models. So I'm going to try and give you a couple of patterns. I can't go into the depth of it on this 45-minute or an hour presentation, but I'm going to give you some places to go look and find which pattern matches you the most. And then we're going to give you a forecast. We built our business around analytics. I'll tell you where we think things are headed and where we're investing, and hopefully parts of those are relevant to you as you plan the future of analytics, either in your organization or for you as your skills go. So nucomp, I know I see tons of people on the line here that are already familiar with us and work with us and have for a long time. If you haven't, nucomp only does analytics. Data is our world, and we've been doing that since the 90s, before my time. We don't specialize in any given industry or practice or department. Analytics is pervasive. So whether it's insurance or oil and gas or finance or HR, we are there and have been there. The technology partners on the bottom are very important to us. So obviously we can't be experts in everything. That's not to say we don't have technical skills in a bunch of other technologies. these are the ones that we've decided to kind of bet on, that we are seeing win over and over. We're not early adopters. We wait until some of these technologies and vendors have really established themselves, and then we say, okay, we see a pattern there, especially in the Canadian market. This is viable, from a financial perspective, and the technology looks good and the organization looks good. We're going to invest. So I encourage you to check out some of those technologies if you're not already familiar with them. And finally, just to understand what makes up NuComp, this is what we call our DNA. So you can think of these as our pillars or our practices within NuComp. I spend a lot of my time in our BI and AI and open source practices. Our part 2 of this is going to focus, more on that data management side of it. So, what you're going to see today touches a lot of parts of what NuComp does. And then, we've got dedicated practices for things like financial planning and doing, smarter forecasting, using analytics to do things that maybe were done manually in the past. So that's us. All right, let's get into it. I think a little bit of history is important just to understand how we got here. This is both me telling my story and just telling the story of analytics in general. In the 90s is really when the genesis of BI happened, right? So at that point, these were reports that were built by specialists. They were bringing together information and reports and then giving them out to non-technical users, right? And that was really the structure. It was this kind of bottleneck, centralized, build a report or a model or a cube or whatever, and then give it to a non-technical user. And that got us so far. I think the appetite was to get rid of that bottleneck. And so you kind of saw this shift both in attitude and technology towards self-service. So decentralizing that function. Maybe we're giving users, the ability maybe not to create their own data sets initially, but to at least drag and drop and build their own visualization. It cuts out a lot of the back and forth in design. And that was great because anytime people get their hands on data, they obviously want more and they get hungry for it. And in the background, we're now into the 2010s. What was happening in the world? Well, data was exploding in the world, right? Data exhaust coming off of sensors and all of your web activity and every vehicle in your fleet and every machine in your manufacturing assembly line was generating massive amounts of data. And so maybe your organization wasn't experiencing that, but certainly the big Silicon Valley companies were, and they were building infrastructure to handle it. So, Google and Yahoo and kind of Facebook, these early pioneers of big data, built and open source technologies like Hadoop, which were, built to handle and retrieve massive amounts of information, zettabyte scale. But they built that for themselves. They are engineering and software development firms. That was less accessible to a retail company in Canada or in the Netherlands. And so as they were building out those technologies, they realized, okay, we've got these massive investments in data centers and computing horsepower that just isn't accessible to the rest of the world. There's a business model here. And so that economy of scale allowed them to sell those services, so a database as a service or some computing horsepower or graph processing or whatever you need to do that uses big amounts of computing power. And they said, we'll turn that into a business model. So Amazon went from being a giant logistics and retail company to being a cloud computing company. And so, they can still make massive profits even if they charge you by the second. If you're just spinning up an instance for 11 seconds to run a machine learning algorithm, they're still making money. And so that's where we are with the cloud today. There's cloud service providers that have invested in this infrastructure and sell that as a service to you. And then the cloud itself is kind of causing this ripple effect as we go back and we look at all the ways we used to do things. Now we're re-engineering them. I just want us to agree. I made this kind of as a joke. I think everybody knows how to pronounce the word, but really the cloud, most simply, is just somebody else's computer. In our case, we're doing that over the internet, usually on one of the big cloud providers' platforms. Not always the case. There's some smaller cloud providers too. And when we talk about service levels, I'll get there in a second, but generally the more you want the cloud service provider to do on your behalf, administration-wise, the more you pay for that service, okay? The cloud, somebody else's computers. There's a couple of different flavors of the cloud. Most of the time when we're talking about the cloud, we're talking about public cloud. So Google, AWS, Microsoft Azure, IBM Cloud, Salesforce, Alibaba. There's some big big cloud providers out there. That's generally what we talk about when we talk about the cloud. That's not always the case. There's certainly private clouds. So if you go into the Pentagon, like the Department of Defense, or Goldman Sachs, or organizations that are very strategic, very private, or they have very specific requirements around their data, they might choose to build a private cloud. So whether they host that or they pay somebody else to host the hardware, that's kind of disconnected from the public internet, public cloud. And then we've got the middle ground. So IBM bought Red Hat for this very reason, is that we can sew together a private cloud and a public cloud services and make it look like one giant mesh of services. And so I just wanted to make sure you understood that terminology. All right, that's cloud school. That's as far as I'm going to go just on explaining what the cloud is in general. Let's talk about how this applies to analytics architecture. This is a very stripped down version of analytics reference architecture. If you Google that and hit images, you'll see 100 different versions of this. So this is by no means the gospel on it, but this is just the easiest way that I find to explain it. We've got a couple of functions that we're trying to do as data workers. I want you to think of what is our job as data workers. Our job is to move data from wherever it is, so sitting in a database or with a third-party provider that we buy data from. Maybe it's sitting in a file system somewhere. Our job is to move that data from wherever it is to somewhere where whoever needs it can consume it in whatever format they need. I think if we boil it down to making it that simple, then we stop over engineering these things. And it doesn't look fundamentally different than these patterns have looked in the past. There's a couple of really key considerations now that we use the cloud, and I'm going to go through those in a second. But this is what we're trying to do. In our ingestion and replication, we're trying to either do big lifts of data or we're doing little incremental moves. We need somewhere to land that data. So if you think of, that's our sourcing. So we're doing like real time, to draw an analogy to kind of a shipping company. We're doing real time scheduled extractions from our suppliers. We need somewhere to land all that data in its raw format. So that's like our landing zone. Then we're probably going to do some distribution and packaging. So we're taking something from one supplier, something from another one, and putting it in a new box, and we're giving that to whoever needs it, right? So that's very much how we should think of data too, is just moving data along the supply chain. And then there's a bunch of supporting services. I really don't want to focus on all the supporting services. I think I really want you to understand how we're moving data from A to B, because ultimately, if that's not happening, governance and quality and data science, none of those things can happen. All right, so let's strip away the analogy. This is the actual terminology that we use in a reference architecture. And so kind of take a mental screenshot of that. I'm gonna really strip this down for the rest of today. But think of these capabilities as our core capabilities, okay? Now I'm gonna transform this into a real actual reference architecture that you could take and start building. And so this is what we tend to look at. This is very, very, very stripped down. And I'll go through a little bit of the terminology from left to right, okay? So data ingestion, what is that? This is the extraction and replication of data from the sources, either scheduled in real time. So this is our engine moving data from source to some sort of landing zone. Just about drop that. ELT or ETL, you can see those two acronyms on the screen right there. Those stand for extract, transform, and load, and the order of those letters is important. That's the order in which we do those functions. Different paradigm, different methodology, depending on the kind of data. I'll go into that a little bit later. The data lake, something we're going to spend a lot of time on. This is really just a storage zone for raw data, and then we kind of refine it in a couple of different zones. But I just want you to think of as the data lake as that place that just accepts a bunch of raw data and gets it ready for further refinement, okay? And then the data warehouse. I'm not going to talk too much about data warehousing. In modern architecture, it's kind of funny. The data warehouse has actually just become this massive computing layer. Most of the data often still lives in some sort of data lake, and the data warehouse is this big query engine that knows how to translate from a reporting tool and go get raw data, even if it's out of a CSV. So, often now we're not even replicating data into a data warehouse. It's just a logical tier. But there's all sorts of patterns that we can follow, and I'll talk about those, okay? All right, and I know I'm moving quickly. There's only an hour, and I want to make sure we get through everything. I think it's really important to understand those fundamental architectures, but also we've got a lot to talk about because a lot has changed. And so I could end the presentation there, and you could have built this architecture a couple of years ago. Now that the cloud is inevitable, and for sure, I think COVID accelerated this timeline. I think we've seen in a lot of clients, they just had no choice. You know, their on-premise infrastructure and architecture just can't handle being, you know, having digital stores when they were just physical stores before, or, you know, a remote workforce. So we have to do this, and so it's accelerated, right? This is where I want to spend a little bit of time. I go back and forth on using the term data lake. It is so hype filled and over marketed that I wish I could call it something else. But you know, a data lake is a staging area. It is a file system for raw data, getting it ready for analytics. So, you know, if you've been building data warehouses for a long time, this isn't a new concept. It just maybe wasn't a separate pillar on the diagram before. It was just a staging schema inside of our data warehouse or our database. So where we used to just extract raw data and land it somewhere. Storage is so cheap now, and I'm going to talk about this in ELT and ETL, that this data lake really makes sense. Loading it into a data warehouse on the cloud, that is a more expensive service than a raw data lake. And so there's a very specific reason why we put all of, you think of this as kind of like a cone. We're filtering the amount of data and the complexity of data as we get closer to the right-hand side of this diagram. So data lake, not magic, but certainly a key part of modern infrastructure. I don't think I've seen a modern like data warehouse deployment done in the last 2 years that didn't have some sort of data lake or object store tier. So you really need to consider this. It's kind of funny. I don't know if you follow these. I love following Gartner's hype curve or hype cycle, because this is what we deal with. We're busting myths and hype all the time. And it's really not too hard to find data lakes on this diagram. They're actually all by themselves right there. And you can look at the things, the terminology that Gartner uses is hilarious. If you look at the peak of inflated expectations, hopefully you empathize with somebody in my role where I'm getting asked, you know, how about event stream processing and data catalogs and storytelling and, you know, natural language generation? All those things are at peak hype in analytics right now. And so there's a lot of questions around their viability. Data lakes have slid down the hill, meaning, you know, the hype, I hope, is over. They call it disillusionment. I think it's just reality has set in, that it's not magic. It is critical, and Gartner still says 5 to 10 years, data lakes will be on the productivity plateau, meaning they're operational and you kind of have to have it, right? Just like visual data discovery is today. Where would you be without data visualization? So, but it's taken a long time. If you follow data news, like all the coolest people do, Tuesday was the 15th anniversary of Amazon S3. S3 stands for the Simple Storage Service, and it was Amazon or AWS's first cloud offering to the public market 15 years ago. Well, guess what S3 is? It's a data lake. It's an object store, and they've obviously augmented it over time. But you know, this is one of the very first parts of big data infrastructure and architecture that was deployed on the cloud. So 15 years to get over that curve. You know, it's realistic to say 5 or 10 more years until it's mainstream. So there's a lot around data lakes. I think most important is that we just all agree on what that is. So take the hype away, take the brand names away. I don't really care what technology you use for this, but when we're thinking of the concept of a data lake, here's the things we need to agree on, okay? It is centralized. It can store structured, so rows and columns, table kind of data, semi-structured data, so things like off of sensors or weather data. Often you can still read this as a human, it just kind of looks like HTML. It's usually XML or JSON. Or unstructured data, so PDFs, videos, images, sound files from your call center. A data lake needs to be able to store all the types of data, okay? And that data should not need transformation. It should be able to be landed there raw. A data lake should support something called Lambda architecture. Part 2 of this series on Tuesday, we'll talk about this. But all that means is that it has to be able to handle streaming, so real time, and batch data requirements, so both types of ingestion. And it has to be super elastic, meaning it has to handle very small workloads and still be economically viable, and massive computing requirements. So it has to be able to like accordion in and out based on the workload that's asked of it, okay? So if there's a data lake initiative going on or a data warehouse initiative going on where you live, make sure you keep those check marks in mind, okay? These kind of go hand in hand, the concept of ETL and ELT and a data lake. And I alluded to this earlier. Historically, we used to follow that top path. So when we went and extracted from a data source, we used to do a bunch of transformations in flight. So we were kind of fixing the plane as we flew it, right? And then we would put that perfectly structured in a data warehouse into dimensions and facts, and it was all perfect. We don't do that anymore. There's actually no need for that because that was a bottleneck in and of itself. We had to do, sometimes those jobs would take 10 or 12 hours, and if it failed, you had to start over. So what we do now is we just move all the data. We just bring it into the cloud, into our data lake structure, because storage is so cheap. A terabyte of data in a data lake per month is about 25 bucks. So there's no reason not to bring all the data in anymore. And it really helps. It helps with things like lineage and understanding transformations and reloading historical data. Data scientists love access to raw data, even if it's messy, because even that can tell us something. So I'll draw the path. Let me see if I can actually draw here on the screen. I think I can. Pen. So I'll draw the path for you. So, this is what we do now with data. We are just doing real-time replication into our data lake. Some of that data goes to our data scientists and reports just kind of in raw format. Some of it gets transformed and landed into a data warehouse or a data mart, whatever you want to call it, nice and structured. Now we impose a schema on it at this point, and we feed it to, these can be regulatory reports or financial reports or whatever. But we're trying to handle both of those requirements without having to do this very expensive operation, which is transforming the data in flight. We're avoiding that now, okay? All right, let's move on. I'll stop drawing. I think this is super important. There's a lot going on here, so just let me help you understand what you're looking at. So anything in blue, you are responsible for managing. We're talking about infrastructure here. Anything green, the cloud services provider, Google, Microsoft, Amazon, etc., IBM, are responsible for managing, okay? Obviously, the more you want them to manage, in most cases, it gets a little bit more expensive for that service. However, that's just on the surface, like per hour or per day or whatever that you're paying. If you think about it, if you're not doing upgrades or things like that, maybe you don't need a full-time administrator anymore. Maybe you can deploy that resource on your team somewhere else, a little bit higher value. So in analytics, on this spectrum of as a service, most of you are probably familiar with SaaS or software as a service. In analytics, we generally spend the most of our time on the right side of that diagram, either software or in some cases platforms as a service. So, the cloud services providers are doing most of the IT work for us, hosting, backups, redundancy, geo redundancy, disaster recovery, networking, tuning, monitoring, upgrades, stuff that we've now abstracted away from us. We just pay a fee to the vendor and they manage that for us. That's a total economic calculation that you have to do service by service. You can't just say we only do software as a service. It by database, by function, you have to make this decision. But this is very helpful. We use this internally, just kind of explain it to clients too. So hopefully this is helpful for you. Now, what that does bring with it, so if I'm paying for something, based on how much I use it, that allows the cloud services provider to charge me elastically. And so, as humans, our brains are pretty risk averse, and we favor predictability, right? And so do most corporate budgeting processes. So you can imagine what would happen if somebody said, okay, well, let's budget for this database, and you said, I don't know, depends how much people are going to use it. That's something that organizations are going to have to get used to, right? So, but I think this may be the number one gain from just lifting and shifting to the cloud is elasticity. So where you're getting charged for what you use, no more, no less, and the resources are automatically allocated for us. Look at the graph. I just want you to focus on the static scaling, that graph on the left-hand side, because this is what most environments look like right now. You've paid for some sort of compute capacity. So, this is like server-based pricing. and you've tried to build for the high water line, right? So making sure that we always have enough capacity when everybody runs their month-end reports, we need to make sure that we have enough capacity to do so. So for the first 2/3 of that diagram, we are overpaying, right? We're not using anywhere near our capacity that we've licensed. And then something really terrible happens when our experience workload goes over our IT resources. We either have an outage, we either have frustrated users sitting there waiting for queues and reports to run while everything is full and jobs are running, or our website is slow and we lose customers who maybe would have placed an order and aren't placing orders. So if you think of this, again, totally economically, there's a lot of cases for just, moving to something a little bit more elastic, which the cloud is natively. So as simple and not exciting as this is, this might be your #1 business case for cloud adoption when it comes to analytics. So many architectures are built to handle those peak loads right down to licensing. And so I hope that this means most capacity planning meetings and processes can go away, because those have certainly taken years off my life. And so that's change that I think we can all get behind. It is changed though. And so right down to monitoring and billing, like I took some screenshots from our own Azure environment. This is, if you look at the thing on the left-hand side, this is just spinning up a new data warehouse. But how many of you would know how many data warehouse units, DWUs, to blocks to set aside for a data warehouse project? That's a completely new term that you would need to go and understand at a really nuanced level. So there are brand new ways of thinking about these services. I think some of the stuff that's funny, there's the pricing for storage that I was telling you about at the bottom, $27 per terabyte per month. And then there's a little slider for making this geo-redundant for disaster recovery, i.e. replicating this in a different part of the world. It's going to cost me 7 cents per gigabyte per month. So, economically pretty amazing. But again, it's not easy to budget. You can set up things like spending caps by departments. You can say, finance can't spend over $500, or they can't have more than 4 CPUs spin up underneath the scenes to support their reporting environment. You can split them up by subscription and then do chargebacks. Like, all of this allows you to manage the economics of your environment very differently, but it's for sure a new way. And so you can't just budget, $10,000 a month across the board. It's going to be elastic. I would suggest, this is what seems to work the best, use POCs and proof of concepts and pilots, not just to test the viability of analytics technology, but also to come up with costing models. And so pick things that are representative of what your production environment is going to look like, and that might spin off a costing model. And you're probably thinking, so hopefully, if you're not ahead of me on all of this, you're probably thinking this is pretty new, and it is true. The skills have changed. Our skills as an organization, the whole mix has changed, and the profile of a new comp consultant has certainly changed, even from 4 or 5 years ago. I think what's most important, every role is going to change as you shift to more of an agile methodology. If that's a term that you're familiar with. It just means that we're reacting kind of in real time, right? So the cloud really facilitates and almost demands this I'll use a buzzword, but DevOps, which means that we're doing, as a developer, I'm designing, I'm gathering requirements, I'm doing development, I'm testing, and I'm also often supporting one part of the application, right? And so that used to be spread across UAT departments and stuff. That's really kind of zoomed in on one role now. And so for sure that has changed. I think everybody's going to have a gap. And I'll give you some mappings here. I'll flip to a specific mapping in a second. But if you're thinking about training, or you're responsible, or you just care about this stuff, I think what you should do is focus on the people where the biggest gap exists. And that tends to exist on either end of the spectrum. So deep IT infrastructure folks, they're not doing a bunch of that anymore. So they're going to have to get reskilled. A lot of those skills are still super relevant in a cloud world. They're just a different way of thinking. And then I would, on the other end of that is all my kind of end users and developers. They need to understand what's going to happen when they ask for a new project or requirement and expectation management. So really focus on those people that have the biggest gap in their current role to the future role. We gathered a bunch of those. I asked my team to give me some examples of what they've seen. So historical role in that very first column. I think of someone like an ETL developer or a BI architect, somebody that was doing like, building semantic models or logical models in a BI tool. That's not really a role anymore. That role transforms kind of into this all-encompassing data engineering kind of role where you're building that entire pipeline. And so you're seeing some of these roles merge. Data scientist is maybe, everybody puts that on their LinkedIn profile these days. But I think if you have domain expertise and maybe a math background, then you just need to sharpen up on computer science, and some of those concepts you certainly can. And so maybe you can just fill in a couple of holes, and now you've taken your historical role and you are cloud ready. So I wanted this to give you hope. I don't think anybody's irrelevant. We just need to shift and change, just like we have. Okay, but how are we actually going to get there? I think this is important. It's easy to talk about this stuff, but then everybody goes, okay, good luck, off you go to the cloud. But I want to make sure you have a little bit of a pattern to follow. And I tried to make this session as vendor agnostic as I could. So I'm using examples from everybody. This is my favorite. This is Amazon's migration methodology. How there's a lot of considerations behind which of these patterns you follow. And again, it's very granular. By database, by service, you need to look at this map and decide what's best. And it also depends on something like your willingness to be locked into a specific vendor, right? So you could go all software as a service, but now you might be into a proprietary software zone where if you want to migrate off, let's say, Amazon turns evil and blows up the moon, and you don't want to invest in that company anymore. To move your stuff off of AWS might be a challenge if you're locked in 100%. So you really have to think of it. So starting at the top, you can rehost your applications. Think of this as like a lift and shift. So sometimes even just rehosting, taking something that used to run on premise on a server and running it on a VM in the cloud. Often that can save 30+% just because of the elasticity of the cloud, right? We can shut down that service overnight, for example, automatically. So maybe it's not running over weekends or whatever. So that's rehosting. Replatforming, I kind of think of this as like lift, tinker, and shift. So we're not changing the core architecture of anything, but maybe we're moving our database to a database as a service. So same concept, same technology, but maybe just a little bit different. Now it's as a service. Somebody else is doing the administration for us. Replatforming, now we're moving to different products. So maybe we're going from an on-prem solution to something like a SaaS software, like a Workday or Salesforce, something that's cloud native. So we're repurchasing and getting there. Refactoring, this is kind of re-architecting, I guess, which is adding new features that would never have been possible without the cloud. So things like functions and things that containerization, things that are cloud native that you would never be able to do without the power of the cloud. The other two, kind of if you follow the clock all the way around, so retire and retain in gray there. Retire, usually we've seen 10 to 20% of applications get turned off in the IT portfolio. So, whether it was just it's not required anymore, maybe it's a performance monitoring tool or a license, like a CPU monitoring tool that makes sure that we're compliant with capacity-based licensing. Sometimes those just go away just because of the way that the cloud is. Retain, usually this means revisit. I don't think anything gets kept for that long, and so typically we just do nothing, at least for now. Usually priorities or end of life for some of those softwares will take care of it over time. So this is a pattern. If I think in the invitation for this, you will see a link to a blog post I wrote that goes deeper into detail here. There's a link, or you can just Google AWS migration patterns or something like that and get more detail here where you can actually click through and get some more information, okay? Man, where is this all going? Yeah, I wish we had a crystal ball and we knew exactly where it would go because don't know. What we can tell you is that this is where the smoke and the fire is right now. This is where attention and money and resources and executive conversations are going. Cheaper and faster. I think that's only obvious as these services get more commoditized and more cloud adoption happens. Supply and demand, things are going to get cheaper. Investment in infrastructure and hardware, everything just gets better and better and better. Even month to month, we see just natural performance improvements just because somebody like Google or Amazon is upgrading their hardware and infrastructure. They're always doing research, right? And so that service that we're paying for just inherently gets better. So that investment now is one that we'll just appreciate. Edge computing is a really interesting concept if you're not familiar with it, if you're not into the sciences of computing. But the general consensus is that this age of massive data centers out in the desert isn't dead, but certainly is going to come to a plateau. We've got so much computing power right now, right, in our pockets, that we have a ton of untapped computing capability out there in the world. And so when Google Maps, maybe when it needs to do a recalculation, maybe it doesn't need to go to the big expensive data center anymore. Maybe it can just be done locally. We're seeing a lot of like machine learning algorithms, for example, being deployed to the edge and doing it. Those models now live on your phone instead of being run on massive infrastructure. So this push of computing to the edge, so we're going to talk about serverless computing in a second, but that is one factor that allows it, and our requirements for ultra low latency, so connected devices, self-driving cars, that sort of thing. Your Tesla absolutely can't take the time to go back to the data center and run an algorithm and then come back to you if it's trying to decide whether to apply the brakes or not, right? So this concept of edge computing is really, really important. AI engineering, this is DevOps, data ops, model ops in general. This is the digital equivalent of lean, if you're familiar with lean as a manufacturing concept. And if not, you should Google it. But these are manufacturing methodologies that were developed long ago, some starting in the 30s, and then Toyota really doubled down on it in the 80s. But we're applying those same, because remember, we're kind of manufacturing a data pipeline. Those principles are being adopted, especially in the last 10 or 15 years in the IT, specifically in the data and analytics space. So you should definitely read up on those concepts. I alluded to DevOps earlier, where we're kind of doing real-time improvement in our roles now, but the cloud allows us the flexibility to both experiment and react and try new features all in real time. So we're not doing big, massive upgrades and deployments anymore. This is all happening in real time. And then serverless, again, super popular buzzword. I think this is certainly the future of what applications are going to look like. This is the next evolution from monolithic application architecture. Put on your computer science or software engineering hat for a second, but the two generations before this were something called service-oriented architecture, or SOA, and microservices architectures. We're already on this path. This isn't hype or fortune future telling. This is real. You probably heard of something called containerization, technologies like Docker or Kubernetes for cloud-hosted applications. What those allow us to do, modern applications need to be made up of much smaller components, back to kind of our edge conversation, but they need to be made up of smaller components that can run anywhere, right? So on a device or in any location. I think what makes me most hopeful for serverless computing is that we kind of strip away the brand, the religion of the cloud brand, right? So, I'm an Azure developer, and I think now, if I am that, I need to go learn those interfaces and that portal. What serverless computing allows us to do is learn a general interface and then deploy that on any cloud kind of agnostically. And so I hope that it kind of decouples the cloud brand from the developer skills. So I'm not tied to one of those platforms anymore, and that allows us to be a multi-cloud organization. I think that's really cool. Just some closing thoughts for you. I think it's I'm gonna ask a question first, and I'm gonna run a poll. Hopefully you guys are paying attention here, but I'm gonna open a poll. Um, we might actually run two. So I'm gonna ask how many people, just so I understand, and this will give me my my instructions for you going forward. But how many of you are already using the cloud for your analytics architecture, for your analytics environment? Whoa, look at all, everybody's paying attention. That's almost everyone. I wonder if this will surprise you, because I think we've always got this kind of FOMO that everybody else is on this journey, and we are not. Wonder if I can share that with you. But most of the people on the line are not, and that's phenomenal. I think that just tells you what a massive opportunity it is and how much untapped resources and potential we've got to go do this together. So I think that's very, very cool. Um, I'm going to run the other poll after we get done. Can I say hide? Cool. I hope you found that interesting, because I do, for sure. That's more than half of you. I'm going to try and give you a couple of pieces of homework, and I think this is where we can kind of continue to be a little community. Remember, hundreds of people have attended this, and so we're going to collect a bunch of information and insight, and I hope to give that back to you. I'd really like to hear about the use cases that you are working on. So if you've got something and you're thinking something I said today makes you think, even if it's just, I think I could migrate my on-premise SQL Server database to Azure, I'd be interested in hearing that. I want to hear the nature of what people are thinking. Or if you're struggling with a business case and you say, I think we do things so cheaply on-premise that I don't think the economics of the cloud make sense. I want to hear that. So my email address is public. Please share that stuff with me. I think it would be really cool. One of the concepts in here, I hope it jumped out at you, maybe more than one, but go really deep. If let's say ETL and ELT is a really fundamental shift for your thinking, go deep. Go Google and search and see what people are saying about it. There's a lot of good Medium articles and stuff just about engineers, both at small organizations and big monsters. That Twitter, for example, is writing about how they do it. Go really deep, and maybe that'll inspire you and take you into all sorts of different parts of this architecture. I think it'd be really cool if you did this same presentation for your team, even if it was just you talking and no slides. If you want help getting ready to do that, or you want a couple of slides or ideas, I'm happy to help you. But I don't want it to just end here. That's hundreds of people. If each of those hundreds shared it with 5 or 10 people, we've got a really wide reach. So I'd love to see you do this for your team. And then I know that sounds funny, but actually take action. Too many of these sessions just end with saying, all right, good luck, but I want to try and give you some inspiration. And before I do that, I'm going to ask a skills-based question. So based on everything that you've seen today, do you feel like you're ready to do this in whatever role you have? And remember, nobody can see this. I can't see who's voting. It just tells me percentages. Thank you. Everybody's paying attention. That's awesome. Okay, I think you're all, oh, I just hit my computer. I think you're all gonna find this extremely interesting, okay? Check out these results. No one's ready. No one feels ready. So you shouldn't feel bad. And nobody's judging. It for sure, do I feel ready? Some days more than others, but the encouraging thing is that you're learning. You're here and you're learning. I think that's super cool. And so I hope you're encouraged that you're not alone. You should ask questions. It's not silly to say that I need help or that I'm Googling and reading, and tell your boss that you're not sure. I'm not sure. I don't know what we should do with migrating to the cloud. I have no idea. And I went to this session and nobody knew, right? So I think that's very cool. Hopefully that's encouraging for you. I'm going to give you some ideas to steal, all right? And here's some things that we've done in the past. I think these are, despite the fact that you just said you're not ready or you're learning, I think this is a great way to learn. And these are 3 things that we do over and over and over again, both as workshops and boot camps. So let's say you get a bunch of CSVs or raw data or Excel files or whatever. I would say go into your cloud portal of choice, spin up a data lake service, takes about 10 seconds. You just got to pick a name. That's probably the hardest part. And drag and drop those CSVs into that data lake structure, then build a little query on top of it, or connect your favorite dashboarding tool right to that data lake and just see. I just want you to see how data flows through that. If you go into Tableau or Power BI or Cognos or whatever, you will see a connector for sure for that data lake repository. That's maybe half a day of investment, and I think you're going to touch a lot of parts of the architecture, from the portal to the data lake to all these connectors and APIs. I think you would learn a ton. Real-time data. I think this is something that is kind of mythical and gets asked for, but we don't really understand what it takes. Hopefully you join me on Tuesday, and I'm going to go deep into this. But let's say your users, or you as a user, always wanted some real-time data. You can build a little event-driven kind of trigger-based replication engine. Sometimes these are called like event hubs. For sure they are in the Azure architecture, but it's something that's sitting there listening or watching for new records and then replicating into a data lake. So that might be two services you have to start, the replication engine and the data lake. And then, I don't know, if you're a Python person, maybe write a little Python to put that in a little graph, or again, connect your BI tool to it. But test out real-time replication. This should take you about a day. I'd set aside a day for this just because there's a little more components to it. And then a bigger challenge if you're feeling up for it. So let's say you have a bunch of PDFs, so unstructured data with interesting data buried in them. Maybe it's got comments or narrative or survey results or something that's not easily structured. Load those into a data lake. Then there's lots of public APIs like Scrapey, or even built into some of these clouds, where it'll scrape the text out of those and put them into a data structure, and then run a little like sentiment analysis or entity analysis on that text. They'll tell you, what are the most common words people are using? Are they angry or happy? What are the entities that are most commonly associated with each other, like bad quality? Those are two words side by side. That might take you, it would take me a morning. It would probably take you a couple of days to a week of chipping away at. But man, think of the potential. That could even be emails. It doesn't have to be PDFs. Something that's just a little more semi-structured, I think, or unstructured would be super cool. And if you need help with those, my address is literally right there. You have access to me and our entire team, and I'll for sure help you through it. Please do join us on Tuesday. That first half where I was talking about DLT and data lakes and replication and management of data, we're going to go deep into that. That's if you want to live in the data side of the world, I think you're going to really like the content and probably hear some things that you hadn't heard of before. So that's on Tuesday at noon here in Calgary, 2 in Toronto. And then the following Tuesday, I'll have this information for you on Tuesday. It's exactly the same. The 30th at 2 o'clock Eastern, I'll go into the data science, data warehousing, that last mile, maybe some open source analytics, the future of BI tools and visualization. I think you would really like that as well. Okay, that is all for today. I thank you very much for joining, and hopefully you got something you can take away from this. Please reach out and tell me what you're planning to do, what you're struggling with. I really look forward to it, and then we'll send it back out to the group so you can all learn from each other. Okay, all right, that's it from us. Thanks, signing off.